All right, ladies and gentlemen, good morning, good evening, good afternoon. Not sure exactly what time you're watching this, but what I wanted to do was to start with number 3 from the homework from yesterday and kind of walk you through how I would go about setting these things up again. Remember, we're talking about geometric probability here, so we're trying to figure out what is the probability of landing within our shaded region. So when you're looking at one like number 3, there's a couple of ways you can go about doing this. You'll notice, first of all, that the large shape is created by a trapezoid. In that trapezoid, there is a rectangle that has been cut out of it. You can think of it that way. Or you can think of it as put these two parts together and you get a triangle. Honestly, I think if I go the triangle route, it might be a little bit messier, so I'm just going to stick with trapezoid, subtract the rectangle to get the area of the shaded region. So the area of the trapezoid is 1/2 our height of 12 times the sum of the bases, 14 plus 20. That's my trapezoid. Subtract the rectangle in the middle, and that's the 12 by 14. Okay, so we go ahead and start typing all that together. One half times 12 times 14 plus 20, and subtract from there 12 times 14. So my numerator here is going to be 36. I have to divide that by the total area, the biggest shape. Well, the biggest shape here again is the trapezoid. So I have to re-figure out the area of the trapezoid. So that was 1/2 times 12 times the 14 plus 20. And this becomes my denominator, the 204. So 36 over 204. And that should give me 3/17. And that would be the geometric probability of number 3. Okay. On number 4, what I did is I just kind of rewrote the 4 and the 3. The 4 was all the way across, the 3 is here. Now, to find the area of the shaded region, we have a rectangle, the 4 by 3. And then you have to subtract out, and we'll put this in parentheses because there's 2 circles we have to deal with. So if going all the way across is 4, that means this has a diameter of 2, and this has a diameter of 2, which means this has a radius of 1, and this has a radius of 1. So what we do is we have 2 circles of pi r squared. Well, the radius is 1, and we have to square the 1. And then we would divide all this by the overall, again, which is 4 by 3, which is 12. So in order to put this in the calculator, we know that 4 times 3 is 12. And then we have to subtract from that. Well, 1 squared is 1. 1 times pi is pi, and this is 2 pi. So what you have to do is put this in parentheses, 2 pi. Anytime you have a pi value and you're doing something in front of it, whether it's adding or subtracting, you have to put the number with the pi in parentheses to make it work. That value is your numerator. Put that, so sorry about that. The wrong button there. So we'll go back. This was our answer. And I'm going to divide that by 12 because that was my denominator. So my geometric probability of landing in the shaded region here is 0.48 if I round that to 2 decimal places. Not all the times are you going to get clean fractions. Sometimes you get decimals, and that's okay, just as long as your decimal is between 0 and 1. As we got down to number 5, your shaded region was the circle. The large circle here had a radius of 4. Well, that meant that this shaded circle had a diameter of 4, which means it has a radius of 2. So to get the area of the shaded region here, we have 2 squared pi, which is 4 pi. And to that, we have to divide it by the area of the large circle, which has a radius of 4, so 4 squared pi, which would have been 16 pi. So when you put this in the calculator, again, use the fraction bar, 4 pi over 16 pi, hit enter, and you get 1/4, or 0.25. Then lastly, this was a little tricky one on number 6. To get the shaded region here, this is what we call the donut hole. So this inner circle has a radius of 1, and then this part is 2, which means this circle has a radius of 3. To this circle, to get to the radius, to get to the shaded part, I'd have to subtract out the donut hole. So we have a 3 squared pi, which is easy, that's 9 pi. And then to that, I have to subtract out this inner circle, which was 1 squared pi, 1 pi. So my shaded region is 8 pi. From here, we know that this is 1, this is 2, and this is 2. So 2 plus 1 is 5. So the whole circle is 5 squared pi, so that becomes 25 pi. So if I did this correctly in the calculator, 8 pi over 25 pi, I bet you it just says 8/25. And that's what we get. So what I did today is on the formative side again, I've got, I think there's 5 questions, very similar to these guys here, where you're going to find the area of the shaded region. Please make sure you use your calculator, show the work of what you're doing, and go from there. If you got any questions, shoot me an email. We'll talk to you guys later.